Howdy folks. Thought I'd do another one of those start with the end in mind introductions for the 5C tool holder. And these are all the ancillary parts, some of which I've already documented the making of. And I just wanted to touch them and cover what it all looks like together, so to speak. So we've got the index plate here. I covered that in a previous video. That's the 1/8 inch steel plate. And then here's all the small parts that you're going to see made in this video here. It's the plunger knob, and the index wheel. I keep calling this the index wheel, hand wheel. There's the engravings. Hopefully that shows up. I'm trying to take advantage of the natural sunlight here. Today is Martin Luther King Day, 2022. So I've got the day off from work, and I'll be able to get a little work done and think about his legacy for the entire world. So just a nice special moment, special day. And if you were like me and you grew up in the 1960s and 70s, you understand what I'm talking about. So I won't belabor the point, but I did want to honor his memory. Anyway, here is the piece, the plunger. I've got it put together. I had it loosely put into the index plate, hand wheel, so to speak. So we'll put that aside for now. Let me point out one thing before I do that. The shoulder, this is how the parts will fit together, and the index plate butts up against the shoulder there, and then there's that nut that I covered making, or I do cover making in this video, that tightens it all up. And obviously I've left off the key, but I'll show that in the video too. So those parts we'll put aside. This is kind of cool. This is Dan. He loved to fish as his handle, and he created a modified plunger, which it looks like it works perfectly, fits together nicely. The point here is 1/8 inch drill rod, and it goes into these little 1/8 inch holes on the index plate. And as you can see, it's a nice fit there. And let me take it apart for you, and you can kind of see all the pieces. But the idea is that the plunger pulls back. It's spring loaded, so you can pull back and reposition into another. These holes are 30 degrees apart, so there's 12 of them, 30 degrees apart. So you can index that with the index plunger. I'm really pleased how this thing came out. Thank you, Dan, for making those drawings available. They're on the quorngroups.io group. And so let me take it apart piece by piece, using the hex key to loosen the 540 screw here. And again, you can buy of all things, Harbor Freight has a set of set screws that you can buy from in their set screw pack. They call the 540, they call it a 1/8 inch 40. But so here's the knob, all completely machined and everything, and I covered that in this video. This is the plunger body itself. I covered making that in the video. And here is the plunger pin and spring. The spring is from an ordinary ballpoint pen that just happens to be the perfect size. You just needs to be able to fit over the 1/8 inch drill rod here, and the outside diameter is less than the 3/16 inch sleeve on it. So that's how it goes together. This all fits through. There's a shoulder inside here, if you will, and so the spring fits in. You put this together, and then you can use the 540 screw to tighten that down. So I hope that all makes sense. I just think it's helpful, and part of the beauty of YouTube is to see how all these things fit together. So now that I've got that, if you'll stay tuned for the next few minutes, you'll see the making of several of these parts. And thanks again. Welcome again to the new subscribers. As I upload this, I'll get busy on marking out the actual 5C casting. That's the only thing that's left to do, is to mark this out, put the cotters in, and then bore the holes, and very carefully make the mount for the index plate here. So I'll cover that. That'll all be in the next video. Thanks again for watching, everybody. Stay tuned and watch how I made these parts. Thank you. Okay, working on the index plate, or aka hand wheel for the 5C tool holder. This is the piece of gray 1-inch thick aluminum that I got from Russ. I cut it down last night and milled it to about 3.5 by 3.5 square, and I've got it in the mill vise now. I've already bored out to 1 inch, which is the biggest drills that I have, and so while I still have the drill truck in, I've drilled and tapped for the 5/16 24 thread. I'm tapping it right now using my favorite tapping stuff, the tap paste. So I'll get this tapped, and then I'll get the boring head out. I'll take the drill chuck out, put the boring head in, and I'm going to try boring out the center portion, and then while it's still in the mill here, the last thing I can do to it is to mill a slot for the 3/32 inch keyway key slot that I'm going to use. So I'll get that all done over here. Like I said, bore out the center of it, and then I'll be able to take it over to the lathe. Okay, I just finished boring out the hole here with my trusty ancient Criterion boring head, and I bored it out. This is exactly, it's about, well, I think 2 thou over, so it's, just a nice slip fit. The shoulder engages there. This is the 5C Collet holder spindle, and this will become, hopefully, the index plate. So nice fit there. As you can see, it doesn't want to sink down. Have to kind of press it in. So it's a light press sliding fit there. And so when this thing gets machined all the way down, it'll be concave on the inside here. But so far so good with the process. I'm going to take the small boring head off and put the big one on so that I can clear out a much larger hole. I'll tackle that in the next episode, probably tomorrow. Okay, I'm going to try to shoot this left-handed, so I'm going to apologize in advance, but my idea is working okay so far. The 3-inch large boring head from Shars is working really nicely. As you can see, I've got it in back gear. I'm going really slowly, and the reason I did that is the thing, it has quite a bit of mass, and it vibrates a good bit. So what I'm doing, I'm feeding it by hand just to go down to the 1/2-inch depth, and I'm going about, this will be just clear of the tapped and drilled and tapped part. As you can see, I'm advancing it down about 10 thou. You can't probably hear anything, but it's making, and it was really bad, like an interrupted cut while I was boring through the portion that's drilled and tapped over there. So you can hear it. You hear it making a little chirping noise. It's because I'm feeding it so slowly. But I'm eyeballing it with the quill DRO, and when I get just a little bit above about 0.498 thou, when I back it off. Alright. So it's taken a while, but I've been out here enjoying myself, listening to the ball game on the radio, and it's working okay. I mean, it's not perfect. It's not not nearly as much fun as doing boring, or as fast as doing boring on the lathe, but it's working okay. So I'm going to go out. I got to take this hole out to 2 3/4 inches. So I'll just make a few more passes. I'm cutting about 50 thou, about a 25 thou depth of cut, 50 thou diameter each pass. And here I just finished milling the 3/32 inch slot. Dan had a good idea, I thought it was a good idea, about using a normal, like half-moon shaped key in the spindle. So I've done that. I just milled the slot for it. It's a 3/32 inch key. I'm going to test fit that in just a second here. I'll show you what that looks like. Okay, so there's the 3/32 inch hole. I've just cleaned this up a little bit. And here is that's the half-moon key I was talking about. It's not Loctited in place or anything yet. It's just pressed in there. So it might flop loose while I'm trying to test fit. I really haven't successfully test fit this yet, so you get to see it. There we go. Look, it works perfect. Very nice. Shake-free fit inside there. So now my game plan is that I'll be able to mark off the corners here, cut them off in the bandsaw, and then put this in the lathe and turn the outside of it round. So There we go. Thanks, Dan, for a great suggestion. I think this is a lot better than the round key idea that is on these original drawings. So I'll keep you posted as we go along here. And here is the index plate in progress with the corners cut off it on the bandsaw. There's the little corners that I cut off. I need to take it to the belt sander, smooth these edges down a little bit, deburr it, and then the plan is to put it on the lathe on the 3-jaw chuck and expand it, have the chuck jaws inside here where my thumb is, and expand it, and then I can turn the outside around. Just to show you the setup here, I've got the index plate blank with the corners sawed off, and as you can see I cut up a little business card to use so I can machine these right to the edge there. I'll do that the last thing probably. But I also wanted to make sure, even though I'm using a 3-jaw, I took extra pain to, oh, that's where the little lip is, darn it. To make sure it's, I keep getting it in the valley there. But I've lined this thing up to make sure there's no run out, to make sure it's as aligned as possible. You can do that with a 3-jaw. Get it in, tap it if you need to a little bit. And this 3-jaw that I got came with my Grizzly lathe is pretty accurate, so I'm pretty happy with this. And this doesn't have to be super perfect accurate on the outside anyway. I mean, the degree marks will be on here, but the basic idea is to turn this down to 3 1/4 inches overall, and then 3 inches in the diameter that will go up against the back plate, and that's the part that will get degreed. So I'll bring you back when that's good. Here I am taking off a little bit of the rounding it a little bit. Got the auto feed going. I love the auto feed feature on my lathe, and as you can see, interrupted cuts are terrible. Really murder on your tool. So I've got a high-speed, this is aluminum, got a high-speed steel tool in there, and it's one that I made years ago for my shaper. It's like a rounding tool. Hang on a second, I'll pull this. I'm trying to go in as close as I can to that paper using my DRO to go right up to just about 1 inch, which is the thickness of the aluminum. So I want to get as much rounded as I can. Realizing I may have to reverse it, so this is, I'll show you the DRO. Let's go, I'm going to go like right up a thou away from the edge there, from the paper. Okay, so take it out, I'll show you the high-speed steel bit going around, and then we cut the motor off, and you can see how around are we so far. There you can see we've taken some of it off. I'll keep working on this and bring you back when it's pretty well round. Okay, so that worked out pretty well. I got this part down to 3 inches exactly, and I left a little rim here, as you can see, that will be up for the knurling. I'll just have to reverse this around, but I want to show how that fits against the back plate. It's a perfect fit, so very excited about that. This is the part that will get degreed here. This part will get knurled, and this remaining little flange part will get turned off. I'll do that tomorrow. Alright, so here I've flipped around the index plate and put it in. As you can see, since I'm using aluminum, I put it in very carefully with some brass to protect the aluminum inside the 3-jaw. I reversed the jaws around so I could grip it this way, and I'll cut this, basically what it is, a flange. I'm going to reduce this off so that I can have the raised part that's hopefully going to be knurled. Have that clean. I wanted to show this part. I had to get a little creative with the setup. For my little homemade knurling tool here, did not have the side clearance that I needed to get in tight on this index plate, aka hand wheel. But I'll show you the setup. So I had this old Armstrong one, which still had a little life left in it, and I just clamped it to my tool post and have been running it this way. Put a little lubricant on there. Turn it back and forth a little bit. I wasn't sure it was going to work, but I'm pleased to report it actually has worked pretty well. Rotate this, let it run. I fed it in really gradually because we're talking about an aluminum part here. As you can see, it's barely held on. I've got little brass grips there to protect the aluminum from the vice jaws. I'm being really careful with how much I feed it if you can see that very well, but it actually has a really good feel. Really nice knurl there. So I think that's going to clean up good. Pretty excited about that. I'll probably put a little wire wheel. Let me back this off and wire wheel it real quick. Got a little brass wire here. Kind of clean that up, see what it looks like. Turning the lathe slow. They kind of have a odd setup like this. You use 70 RPM. I might have to file that a little bit. We'll put a little sandpaper on it. Let's see what it looks like now. Yeah, I'll put a little sandpaper on it just to clean up the knurls, polish it up a little bit. But that feels good, man. It's I think it's going to work out good. Pretty excited about that. So here we go. I wanted to show a couple things. I've got the steel back plate stuck up against the index plate. First of all, it's a really nice fit. Sorry about flipping the camera around like that, but I got the ODs just exactly right. And that's of course it's not fastened to anything yet, but I'm really happy that the center came out lined up like it did. If you can see the hole here and the through hole for the spring point. It's a little difficult to see, I guess. But anyway, that's I think the beauty of doing this stuff in the DRO. I did mar the surface of the aluminum a little bit, even though there was brass there. You can see that little part where one of the jaws was. So I have to buff this out. I have some aluminum polish. I remembered that I've used it on my locomotive because the side rods are made out of aluminum. So I got some of this the stuff that hot rodders use. I can polish this out. I guess I'll use that after I degree this. So that's the next step. Putting this over on the rotary table and setting up for indexing, putting the 360 degree marks, and then stamping it. So really happy with how it came out so far. Pretty excited about it. I'll keep you posted as we go. Just want to show the setup real briefly before I put the index marks on the index plate. First I used my coax indicator and I carefully centered my rotary table. And then I put the index plate on it, and I used I offset it 1 1/8. I used a tap held in one of the R8 collets inside the mill to set the offset here, and then carefully measured on either side first with a Starrett rule, and then using dial calipers to get my plate roughly centered. Then I use the coax indicator, as you can see here. Let me just show you real quick. So I'm indicating it, and I'm within, each tick is a 1/2 thou. So I'm within a 1/2 thou. It's hard to tell because I've got the little little slot for the keyway, the little half moon key. So that's what's making it jump around a little bit, but I'm lined up within a 1/2 thou. I think I'm good to go. I've tightened all this stuff down. Really happy about that. And I sharpened my scriber. This is the same piece of 3/16 inch drill rod that I had formed and hardened before. I used it on my George Thomas rotary table, and I've used it on several projects since. So I've sharpened this up. I've got it ready to go. So I'll put it in the mill, and I'll be ready to do my degree marks on the index plate for the 5C tool holder. Now I'm almost halfway through indexing the index plate. I'm at the 165 degree mark. You probably can't see that, but it's coming along really nicely. Just like the other one, I did an 1/8 inch long, 125 thou for the ones, 3/16 or 188, 190 thou for the 5s, and then a 1/4 inch, 250 thou for the 10s. So I thought I'd take a shot of this. I've moved the clamps a couple times and getting ready to move this one, put it over here so I can continue on around, but it's coming. It hasn't taken forever. I was really hoping I could do this in the daytime, but it's a rainy, cool evening out here, so I'm just out here methodically working my way around. Okay, here's the finished product. I'm going to leave it in there in case I think of anything else I need to do, but I've gone 360 degrees. You can see hopefully you can see that 359 is the last one I made. So I think it came out good. When you one comment I wanted to make is, as you're cutting these, one way you'll know, especially if you have a springy type cutting scribing tool like this, it may not be so important with other types, but with the springy ones, I do have to crank the cutter in. Maybe you go about a third of the way around and have to kind of tighten it up, so to speak. Bring the table back this way, maybe a thou or something. You can tell, you can just kind of feel as you're making the cut. Let me back out a little bit. This is how I do it. I bring down, and I'm watching my DRO, and you can just feel if you don't feel much resistance. And after about a third, I think there's a little spring gets imparted into the tool. So just tighten it up on your DRO just a wee bit. I probably, over the course of the whole thing, probably about 3/1000ths. I think my offset was 1.948 when I started, so I probably tightened up 3/1000ths that way, if that makes any sense. So thanks for watching, everybody. I'll keep you posted as we go along here. Hey everybody, I'm working on the plunger, the knob for the 5C tool holder plunger, and as you can see, I've basically got the piece of steel formed. It's 3/4 inch steel, and you turn this part down to 690, knurl this part, and I turned a stub down here for future machining. You'll see that in a minute. And I started drilling out the hole, and it called for a strange dimension, which 451 thou, and I don't have anything that size, and I don't have a boring tool that tiny. So what I decided to do was use 29/64. So I've drilled it out, and then since the dimensions call for a flat bottom there, what I did, I went ahead and made a flat bottom drill. If you followed any of my videos on making the brass parts for the steam valves, for my locomotive, you'll notice I have some videos about flat bottom drills. This one's not perfect, but it'll get the job done. So use that, and it'll add to my collection of flat bottom drills. Okay, just about done with the plunger knob. As you can see, I've cut the notch in the mill here, and drilled and tapped the 540 hole here for the set screw. If you're wondering, you can get 540, they call them 1/8 inch 40 set screws in packs from Harbor Freight. I was surprised to find that, but very pleased about that. It's not a custom order McMaster thing anymore. So got the notch milled in. Next thing to do is take this out, put the 5C collet back in the lathe, and do the cutoff and round the back of it. Okay, about halfway through making the plunger body. Pretty simple part. I just got done turning the outer diameters, and I've threaded the 5/16 24 part there using my little carbide external threading. And then next things will be just to drill it out and part it off. Hey, I'm going to wrap it up for the evening and go in, and I'll show this how this all works together tomorrow. But here's all the parts for the index plate. Here's the nice indexing done. It came out really nice. I haven't even buffed this out yet. I just barely ran a file over it to knock off some of the high spots with the index marks. But that came out good. I've got the little plunger knob, and the Loctite is drying on this. I used the green Loctite. This is the part that will go through the index plate itself, or the back plate. And here's a little spring that will be used. So I'm going to let this dry overnight, and I'll show the assembly tomorrow, show you how it all works, and then I'll get started on the actual cast iron plate. The cast iron tool holder.